The best thing about Riverpod is that it gives you a lot of freedom. You can do things that you couldn't easily do with Provider. Unfortunately, that freedom comes at a cost, because the worst thing about Riverpod is that it gives you too much freedom. Should I use Change Notifier, StateNotifier, StateProvider, a combination of all three? Where do I put my providers? Which option should I use to read a provider? What is a family provider? When do I use it? Should I use hooks? What is freezed? Ugh. Choices. All of these choices don't make life easy, but it also shouldn't make life hard. The opposite, in fact.
We're not cavemen! We have technology!
Just because there are many choices doesn't mean you have to find the absolute best one. The best solution is the one that works for you or works for the problem that you're trying to solve. Don't see a limitation in Riverpod when you're not sure what to use. There is no best way to do something. Use what you're familiar with or branch out and explore to see if there's an easier way to solve your current problem. And that's what I hope to accomplish in this series, to maybe expand the way that you see and think about problems. And the best way to do that is to tackle the same problem in a number of different ways and explore the benefits. So we'll do just that in this first video. We'll make a counter app. I know, easy, but bear with me, hey? We'll make the counter app in 3 different ways, and we'll make it a little bit harder at the end by using our own custom counter model, and then also throw in a couple of extra examples to see how we can easily combine providers together. So buckle in, subscribe, and get ready. This is the first of a couple of videos to help us get to grips with Riverpod, and we'll start by exploring Change Notifier, StateNotifier, and StateProvider. Okay, so let's jump straight into the code. You can see that I've made 3 different pages, so a Change Notifier page, a StateNotifier page, and a StateProvider. And all of these are just counters that do the exact same thing, but just in 3 different ways. So this code is available on GitHub, and you can explore this at your own time. And we will just take a look at the actual state management behind them. And to begin, we will take a look at the Change Notifier provider, as this is something that most people will be familiar with if you're coming from Provider. So in this particular page, this is the widget. So this is what you can see on the screen to the right if we go to the Change Notifier. And for the most part, it looks the same as a normal widget. The only difference is that instead of extending a stateful or a stateless widget, we are extending a consumer widget. And this isn't entirely necessary. There are other ways that we can consume these providers. However, the consumer widget is just an easy way to do it, as the consumer widget allows you to also have this extra scoped reader in the build method. And this scope reader, we will call this watch. This allows us to watch for certain providers. And you can see in this instance, we are watching this private counter provider. So this private counter provider is actually a global variable, but you can see that this is an immutable variable. So we are declaring that this is a final counter provider, and this is of type Change Notifier provider. So now the question might be, where are we adding this provider to our widget tree? And that happens in main.dart. So above our material app, you can see that we have this provider scope. And this is something that you have to do when you're using Riverpod and Flutter together. The provider scope is essentially a configuration widget for Riverpod that just adds all of the providers to the scope of your application. In addition to that, the provider scope allows you to also create overrides. So you will see there's this overrides argument and also an observers argument. And this is something that we will take a look at in future videos. The overrides is extremely nice for testing, and the observers is maybe if you want to do custom logging. So maybe log every time a provider changes its value. But as I said, we will take a look at that in a future video. That is really the main thing to understand. We have this provider scope, and then throughout our application, we create providers in a way like this. This does not have to be a private variable. This can be public, and this can also be at any location in our application. It doesn't need to be in the same file. You should essentially place it wherever it makes sense for you. Under most circumstances, it makes sense to create the providers where you will need them. So in this instance, we will only need this provider for this particular page, and we will create separate counter providers when we use the other different types of notifiers. So let's jump into the code for the Change Notifier provider. And this is something that you will be familiar with if you come from Provider. And as you can see, it is very straightforward. We have our class called Counter Change Notifier, which extends the Change Notifier class. Then we have a count field, which we set as a default value of 0. However, we can optionally override this because of the brackets. And then we have one method called increment. And in the increment method, we increment the counter and then we call notify listeners. And notify listeners is a function that is exposed by change_notifier. And what this will allow us to do is it will allow the counter provider to trigger an update every time the counter change_notifier changes. So basically every time we call notify listeners, that will cause the counter provider to update. And as a result, where we watch for this particular counter provider, that will result in this entire build method being called again. And that is exactly what we want. So here you can see we get a reference to the counter, and then in the text widget, we say counter.count. So we just get this count int value over here. And then great, we can also increment it by calling context.read. Then we pass in the actual counter provider, and then we call increment. If we wanted to, then we could also do the following. We can say counter.increment and be done, because we already have a reference to the actual counter provider. But generally it is best practice to say context.read, because in the future we might refactor this. So for example, if I wanted to extract this widget and just call this my floating button, there you go. We have working state. We don't need to get reference to the counter provider again. We can just call the increment by saying context.read. And as you can see, we aren't passing in extra parameters. And this is still working in the exact same way. So one point that I'm trying to make in this video is that this is a perfectly reasonable solution. You can technically stop the video right here, and if you're happy using change notifiers, then you don't have to proceed. However, there are benefits to using something like a StateNotifier, or as we will see now, a StateProvider. And we will explore those benefits in a moment. The big problem with change_notifier is the fact that this data is mutable. In a simple counter application like this, it is very easy to manage our state. We have a count variable, we increment it, we notify our listeners. But the moment we manage more state, it becomes a lot more complicated to keep track of the different side effects in your application. Maybe you're increasing the counter, but you forgot to call notify listeners. Or maybe because the counter is increased to a certain extent or to a certain value, then another trigger will happen that calls a different state update that you weren't expecting. Change notifiers are great. There is definitely a place to use a change notifier. For me personally, I use a change notifier when I cannot use a state notifier. Now that we have the change notifier out of the way, let's go to a state notifier. And as you can see in this file, we have a class called counter state notifier, extending state notifier, and then we specify the type. And this type that we specify here is the actual state that we will be setting. So in this instance, we are saying that the state is of type int. And same thing, we are passing in a count, and if the count is null, then we set the value to be equal to 0. And then we have an increment method, and here you can see we are directly setting the states of the integer, and we're just calling ++ to increment the value. And this is enough. This will trigger a state update. There's no need to call notify listeners, because every time the state changes value, that will result in the listeners being called. So for example, if we were to say state equals 5, then that will notify the listeners as well. In a moment, we will explore how we can expand this a bit more by making our own custom counter model. And if we take a look at the actual page for this, so if we go to the counter state notifier page, you can see we have a similar process. We have our private counter provider. This time it's a state notifier provider, and we point it to our counter state notifier, and then we just return the counter state notifier. So here we are instantiating that counter state notifier. Then a little bit different in our watch method over here, we are saying counter state provider, and we're watching the states. So let's go to that page, the state notifier, and as you can see, it's working. If we wanted to, we can remove this, and instead of saying counter, we can say counter.state. So this is the exact same thing, but you will see that we get a little bit of a warning that says the member state can only be used within instance members of the subclass of package state notifier. And this is essentially just a safety mechanism to avoid you doing something like this, counter.state equals 7 or 8 or whatever. The idea of using a state notifier is the fact that you want to update your state within this. You don't want to directly expose the state variable or directly update it outside of this class. So in this instance, this is why we say counter.state. We are listening to the state value, and then we're just updating our widgets every time that state changes. And the same thing, we are saying context.read. we're giving the counter provider, and we're calling the increment method. And then finally, if we go to the last example, that is the counter state provider. So now you will see in this instance, we don't have a notifier. We just have this state provider, and this state provider is of type int, and we set the initial value to be equal to 0. And then the same thing, we are watching this counter and we are watching the state of this counter. However, this time we are directly modifying the state. We aren't calling a method called increment. Instead, our floating action button will directly increment the state value. As you can see, if we tap this, it increments, and if we wanted to subtract that, we can do the same. So now the question comes in, when do you use a state provider? When do you use a state notifier? When do you use a change notifier? And the first immediate difference between all of them is the fact that a change notifier has mutable state. Meaning, if we wanted to create something like string name and then also update the name when we increment, that is something that we can do. And we can do that in whatever way we want. We can call notify listeners whenever we want. So it definitely gives you more freedom, but with freedom comes responsibility. Being too loosey-goosey with your code may result in unintentional errors. Maybe you're updating the counts, but you forgot to update the name. Maybe when you update the name, you don't call notify listeners. This is a very contrived example because it's simple, so it might be hard to visualize that this could lead to issues, but there are known reasons why mutable state is considered not bad, but considered something to be careful about. And there are also benefits to using immutable state, so state that cannot change. And this may be a little bit hard to understand because we're using primitives, because we are just using this integer value. So as a demonstration, let's create a new class called counter, and we will say that this is a final int, and we will say this is the count, and then we will create a constructor for this. And then in this counter state notifier, instead of saying the primitive int, we will now give our custom object over here. And the same thing, we will say that we can pass in a counter. And if the counter is null, then we just create a new counter and we set the initial value to be 0. And then over here where we modify the state, now we will say that the state equals the counter, and then we will say the state current count value and plus on that. Actually, that's a lie. We would just need to say +1, and there we go. And excuse me, this shouldn't be equals, just setting it equal to. So now what is happening is you can see that this final int count is immutable. We cannot say counter ++. You need to actually create an entirely new counter model. And the main benefit of this is the fact that it allows you to better reason about the current state of your application. It will also allow you to do something like create a history, because you're creating different states means that you can have a history of all of these different state values. This is something that we will explore more in later videos. But as a prime example, if we save this and let's actually go back to the page where we do these counter state notifier, you will see that we're currently getting an error because we aren't managing the changes that we just made. So now this final counter will actually be a counter. So we just need to say counter.count. And yeah, there we go. It's working in the exact same way. But this time we just have our custom counter class. But something I'd like to demonstrate now is that if we go to the change notifier, and we go to that change notifier page, you will see that here we have our counter, and if we tap it, it increases at one time. But what happens when we now say counter.count and then we just say ++? We basically modify the state outside of the change notifier. Nothing is prohibiting us from doing this, but technically, I mean, we can prohibit ourselves by making this private and exposing a getter of the count. That's definitely something we can do to basically protect ourselves from doing stuff like this. But now when we say plus, we are incrementing it by 2. This is one aspect of what I meant by having side effects. Having mutable state like this allows you to more easily make screw-ups. But that said, using a change notifier is not wrong. I use a change notifier when I can't wrap my head around the way to create a nice state notifier. But when it is state that you can reason about, for example, a list of to-dos or a counter like this, then using immutable state makes it a little bit more easy to reason about, in my opinion. Because technically that is exactly what is happening if we go to the most easy example, or I should say the easiest example, and that is the normal state provider. So in this one where we just return a primitive integer and we are just incrementing that integer. This state is technically not mutable because we are creating an entirely new integer every time we are setting the value. And that is the way you should think about your own models as well, and the benefit of making them immutable. All of this will become easier to understand when we do more complex examples in future videos. But while I have you here, let's actually explore a couple of nice things that Riverpod allows us to do. I'm going to create a new provider, and I'm going to say that this is even provider. And this will just be a normal provider, and we will say that this is a bool. And what we will do here is we will now finally use this reference. So this is a provider reference that basically gives you access to other providers that are already made. It also allows you to do a couple of additional stuff depending on the type of provider it is. And we will explore this a lot more in future videos. But for now, we just want to use it to actually watch other providers. So in this instance, we will watch this provider, and let's just get a reference to that. And what we will do is a simple check to see if we divide this provider by 2, if the remainder value is equal to 0. And we're getting a warning over here because this counter is not state. So we just need to say counter.state, so we get the states of this value. And if it is divided by 2 and it's equal to 0, we will return true, otherwise false. And then we're going to create a new widget. So I'm going to create a stateless widget, and we're going to call this counter is even. And then instead of this being a stateless widget, this will be a consumer widget. And then we need to provide that scoped reader. And then we'll create a final is even, and we will watch for the is even provider. And then we can return a text, and we will say is even. If it is true, then we will return is even. And if it's not true, we will say not even. And then finally, in this example where we have our text for the counter, we're just going to wrap this in a column. And then we can also add the counter is even widget that we just made. And I do believe I'm not at the correct page. So let's go to the state provider page. And you can see that it is even. If we hit increment, it's not even, and it's also subtracting. I forgot to take that away. Okay, so even, not even, not even. And the very interesting thing about this is that this is even provider will only result in the counter is even widget updating when the value it returns changes. So what do I mean by that? If we take a look at this builder and we say print, and we can just say building, and if we take a look at our debug console, every time we hit the increment, it is building because it's going from false to true to false to true. But as an example, if we were to say that this divided by 4, now it won't be rebuilding as often. So let's just clear the console, and you can see that it says not even, is even. Okay, that's not working. I think I need to do a hot restart. Okay, let's go to the state provider, and you can see not even, not even, not even, but it's still building. And the reason that it is building is because the counter is changing. But a thing to note is that the counter is even is not changing. So this is something that I forgot. We will also need to say that this counter is even should be a constant value. Okay, and 3rd time's the charm. So let's test it again. Now you can see that it changed from not even to is even, and now it did a building. And if we do it again, it will build, but now it won't build until the value changes again. So in the next increment, it will build again. And this is just one small way that Provider allows us to avoid unnecessary rebuilds in our application, and how it allows us to easily create providers from other providers. And we can do some really amazing stuff with this. And in the future, where we do more complex examples, for example, networking, this will become very evident. There is still a ton left to be covered with Riverpod, and I'm super excited to tell you more about it, because honestly, I love using it. And although sometimes I get caught in this situation where I try and find the best solution when it's not really necessary. It's also extremely fun, and it's very rewarding when you find a unique way to use different providers together. So I'm looking forward to telling you more about that, and yeah, I'll check you in the next one. Cheers.